Today our objective is to learn about the midsegments of triangles and to learn those properties and to learn how to solve problems using those properties. The reason that we want to do that is because there are jobs out there where you have to know properties of the midsegments. There are people called volcanologists that actually use the midsegments of triangles to figure out the approximate measurement of the distance across the volcano. We're actually going to fold a midsegment of a triangle so that you understand what it is. Okay? So everybody has a triangle, right? I want you to take two corners of your triangle, any two corners, and fold them together exactly. When you open it up, you have two little pinch marks on your triangle. Take a ruler and connect your two little dots. And what we're going to do is a little discovery activity where you learn the characteristics or the properties of that midsegment. You're going to measure this section right here. We'll call it the top left. Okay. Here's the 6 measurements that I need.
Because this is parallel with the base. That's it.
Okay, if someone at your table needs help, please lean over and help them explain what we're doing. Let's let the person that's in the north chair, you're going to be the recorder. Record each person's data. So what does it look like maybe is going to happen with all your triangles? Like she has 13.1 and 13.2.
You're going to become.
Okay, this right here, she has 12.1 and 12.1. Look at your triangles and see if you have the same kind of pattern. I want you to look at patterns with everybody's triangle, each person's triangle, and see if you can come up with some rules about midsegments. What do they do? What do they look like in every triangle? Because you guys had all different triangles. Some of you had right triangles. Some of you had acute triangles. The midsegment has some rules that work no matter which kind of triangle you have. So I want you to see if you can come up with those properties. In your group, talk about what patterns you saw.
Our halves of the same side are both about the same. Every
Oh, yeah.
And then these are all about the same. Should I write halves of the same side are equal?
Well, they're not.
Well, they're really close.
Several of you had some great ideas. You saw some great patterns. Susan?
The midsegment is half of the base.
Okay. They found out that the midsegment. What else did we discover? Guillermo?
This midsection divided half of the triangle, and like the top left section, the bottom left section.
Okay, so it made the left side of the triangle get split into 2 equal pieces. Okay, so it, what's a word that we use to say something got cut in half? Bisected.
It makes a smaller, similar triangle.
Oh, I like that. It makes a smaller, similar triangle. We just got finished talking about similar triangles in Unit 4. Let's pretend that we're making a prop for a movie. Look right here at the teeth. If I draw that triangle in, and let's say that I made the teeth on my prop 1 foot apart, how big do I need to make that mouth to make it in proportion correctly with these triangles? 2 feet. How come? Which one of those reasons over there tell me that the mouth has to be 2 feet?
The midsection is the half of the base.
Very good. Talk in your group about about knowing the properties of the midsegment, how that would help a volcanologist whenever they're trying to figure out the distance across that volcano or distance across a crater.
If we measure a volcano, it goes like this. And you're measuring this. It's like
If you look at your data sheet down at the bottom, there's a triangle that has X, Y, and Z. In your group, talk about what the value of X, Y, and Z have to be because of the given information.
6 because it's half of 12.
Right here is 10.3, that one's 10.2. Mine says close to.
Remember, you times that, but you divide it by 2.
So then 12 divided by 2 would be 6, and then 6 times 2 would be 12.
And then since these two are the same as they were up there in our chart here too, so then so y would become 7, and then x would become y because it's in the middle.
I'm going to think aloud what I would do to solve this problem. So I don't want you working it. I just want you watching what I'm doing and what I'm thinking when I work this problem. Okay? So everybody put your pencils down, and I want your eyes on the board, and I want you listening to what I say. Think about how I'm thinking about this problem. Okay. No, looking at my mid-segment properties, I know that if I have the mid-segment, it's half of that base. So in my mind, I think if it's half of the base, then if I had the mid-segment twice, so my thought process is, if I know the mid-segment is half of the base, then if I have two of those, it has to equal the base. So now I've brought it to an algebra problem, and I know how to do algebra problems. What I want you to do is think about another way to work that problem, because you know in math there's always more than one way to get to our answer. So talk about that in your group and see if you can think of another way to set up an equation to find the value of A.
Oh, I know.
Okay, tell me.
No, like, 6A?
No, that wasn't what you said. You said half of the base was 3A. How can I use that? Because that's on the right track. What do you know about the mid-segment? Okay, what does is mean in math? Equals. So you just, okay, tell me.
All right. You write it down?
Okay, write it. He wants to write it down.
Would it be like that?
Perfect. Yes. Okay, do you mind to say that out loud to the class? Hugo came up with a great idea. I want you guys to hear his idea. Okay, tell us what you did, Hugo.
First, I cut the base in half. No, it's half, so it's 3A.
Okay.
And then it's just,
So he said the base was 6A, and he cut it in half, so now it's 3A. Do you see why it's 3A? Okay.
then I put A plus A equals 3A.
So then he put on his paper A plus 8 equals 3A, because the 3A was half of his base. Do you see that mathematical thinking there? Yes. Is that good math logic? Yes. Absolutely. Turn in the books to page 325. We're going to try one of these on our own. On the back of your triangle, I want you by yourself to try number 22. Talk to your neighbor and see if you got the same answer.
22. Oh my God.
Well, how'd you work yours?
Probably the same way you did.
Anybody do it the neat way?
35 over 2 things? Yeah, no. I tried, but that was 17s and
Tell me what you were thinking when you did this.
8.
Where did the 9 come from? Okay. Tell me what you know about a mid-segment. First thing we learned from doing our little group activity was that the mid-segment is half of the base. Write down at least 3 things that you learned today about your triangle.
Cut the left side in half. This side is always a smaller version of this.
It's kind of the same thing as it makes a similar small triangle.
Why are we using the word bisect? Because it means to cut into 2 equal parts. So
Okay.
why are we using it?
Okay, think about what I said. I said it bisected the left side. That means it cut the left side into 2 equal parts. Did it do that?
Yeah.
Times your base twice.
Okay, think about what that first one said. Everybody get 3? Yes. Tell me one, Santos.
The mid-segment is half of the base.
Mid-segment's half of the base, very good. Give me a different one. And what do you know about those 2 triangles? We had a word that we used in Unit 4. It starts with an S. Tell her. Similar, okay. Our objective was to learn properties of triangle midsegments. Did we learn the properties of triangle midsegments? The other thing was that we needed to use that information to solve problems. Can we solve problems? Using that information? Absolutely. Every one of us did that.